Tonight, the time before time began, the universe, black holes, God and the laws of science. Professor Stephen Hawking, Dr. Carl Sagan and Arthur C. Clarke discuss the mysteries man faces as he starts to explore the stars. Dreadful disabilities prevent Stephen Hawking from speaking a word, but he's risen above them to become a brilliant mathematician and teacher. Using a computer-driven voice synthesizer, he's told the world how the universe began, and now he's seeking the ultimate theory of how it works. Arthur C. Clarke invented the communication satellite long before the technology existed to launch one. That vision of the future fathered the global village. His novels and stories, including 2001: A Space Odyssey, have inspired a generation of real-life astronauts. Carl Sagan sent man's first messages to the stars aboard NASA space probes. He's sure we're not alone in the cosmic wilderness. Dr. Sagan joined our discussion from Cornell University in New York State, so I checked whether he could hear us over one of Arthur's satellites.
Yes, communication satellite technology is working very well, thank you.
Arthur, can you hear all right?
I can hear fine.
And Professor Hawking, are you in touch with Carl Sagan?
Yes.
Professor Hawking, in fact, has just made publishing history by writing a book about hard theoretical science which has outsold even Michael Jackson in the bestseller lists. It's called A Brief History of Time, and we'll be talking about the concepts that are in it. Now, Stephen Hawking is engaged in a search for the ultimate answer, a grand, unified theory that would explain everything. Stephen Hawking, that is quite an agenda. How are you getting on with it? Let me just explain that what happens when Professor Hawking wishes to speak. He lost his voice a couple of years ago and now has to use a voice synthesizer, and he can control a squeeze box in his hand, and on the VDU screen on the arm of his chair he's got a vocabulary which scrolls through, and he can pick out the words that he wants, and these words are then assembled into a sentence, and when the sentence is ready then he can process it through the voice synthesizer. So whenever you're ready, Professor Hawking, we'd like to hear from you.
In the last 300 years, we have discovered the laws that govern the universe in all but the most extreme conditions. I think there is a reasonable chance that we may find a complete set of laws by the end of the century if we don't blow ourselves up first. If we do find a complete unified theory, it will be a great triumph, not just for scientists, but for ordinary people as well. In time, the unified theory would be simplified and taught in schools, at least in outline. Then, everyone would have some idea of how the universe works.
Well, that is a tremendous vision. Now, Carl Sagan, you wrote an introduction to the book, and one of the striking things that you said is that it's only children nowadays who ask the big questions because they don't know enough not to.
What I was trying to get across was the notion that the school systems, it seems to me, have a attitude of discouragement of asking fundamental questions. If a 5 or 6 year old asks why the moon is round or why grass is green, the usual adult answer, at least in my experience, is to discourage the child. Say, what shape did you expect the moon to be? Square? Or what color did you expect the grass to be? Blue? Instead of saying that those are interesting questions, let's try to find out the answer, or maybe nobody knows the answer, and when you grow up, you'll be able to discover the answer. It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Excellent. Now, I have planned a reasonably finite structure for our little colloquium, and I'd like to start, if I may, with Professor Hawking. How did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past. In fact, one can show that all the galaxies must have been on top of each other about 15 billion years ago. This was a real Big Bang, not a puny thing that took place on the stock exchange a couple of years ago. It was the beginning of the universe and of time itself. Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, I'd like to stay with this basic proposition for the time being, the Big Bang theory. And to come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies, was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence.
Well, what I have in my mind is a picture that Carl Sagan had been leading me towards of the whole universe in quite amazingly small packages, like putting the whole world into a matchbox, as it were, immensely dense and immensely tiny. And in fact, so tiny it's kind of disappearing into a little point. Is this the earliest imaginable point that our minds are taking us to so far, Carl Sagan?
Well, as Dr. Hawking said, the galaxies are expanding, running away from each other. The further away they are from each other, the faster they are running away. If you run the cosmic movie back into time, you come to a moment, perhaps